Hello everyone, welcome to 526 Database Management. This is week 12. Now let's focus on filtering on grouped data. In the past 2 weeks, we learned simple total, aggregating functions, and group by clause to apply aggregating functions to groups of rows. In this week, we add the last piece of this part. Filtering result after using group by clause. You may ask the question that we have already used where clause to filter result in the past. Can we use the same way to filter result after using aggregating functions with group by? Unfortunately, the answer is no, because there is a constraint in using where to filter data. The constraint is the column name used in the where filter must be one of the columns in the table used in the select statement, which means you can only use column names that have appeared in the table after from clause or after join clause. But the result after applying aggregating functions are not part of the original columns. Luckily, SQL provides having clause to solve the filter problem with group by. We will again use the sales order example database to illustrate the detail. We're going to use the sales order example database, and we look at how many tables. And in this example, we are going to primarily using the orders table. Okay, in the orders table, we have order number, order date, ship date, customer ID, employee ID. And let's look at the sample of the data. We have the order number, order date, ship date, customer ID, employee ID. Let's use orders table, which contains all the orders that all customers have put in the past. If we want to find the number of orders for each customer, we can use the following query that we learned last time. This is by using group by customer ID. We are actually counting how many orders for each customer they have put in the past. And the result is customer 1001 placed 44 orders, 1002 placed 40 orders, etc. Now, if we want to only return customers who have placed more than 40 orders, how can we do that? As I mentioned, count orders is not part of the original table in the orders table, so we cannot use where clause to do those filtering. And SQL actually provide a having clause. Having clause is actually can apply aggregating functions to the columns in the table and then filter something out. Like in this one, we're going to filter the result having count order numbers larger than 40. This gives us only a handful customers where the total number of orders they put is larger than 40. And here we're actually using what we mentioned, the having clause, to solve the problem in one query. And easier than what we have done before, we can actually apply, we can actually associate a new name to the aggregated functions. Like for example, we can use total orders as the new name for count order numbers. And once we define a new name, if the having clause they're going to use a condition that involves this new variable name, we can just use it as it is, right? it returns exactly the same result. So this is actually a little bit easier to read because by define the total order, which is an aggregate function of order numbers, number of rows in the order numbers, we can use that new column name in the having clause. So having, as we just finished here, is going to apply a filter that is to be used for the result after applying the aggregating functions. We can actually use where and having in the same query. Here's the logic. Where will be used first to determine a subset of rows in the table to use. And then group by will only be applied to these subset rows. And after calculating the aggregating functions, having will be used to further filter result out that the aggregated value satisfying some filter conditions. So if we are going to apply the group by for only a subset of data, we need to apply the where clause, and by remove some of the rows from the table from the aggregating function, it is more efficient, much faster to calculate. But where can only be used to filter the original dataset, not the variables or column names after the aggregating functions. Here is an example to find customers who have placed more than 40 orders, and the customer ID are actually between 1015 and 1035. Customer ID is one of the original column name in the table, so we can use where to directly filter customer ID between 1015 and 1035. The total number of orders are results after aggregating functions, and we have to use having on it. So this is how we're going to apply for that. Select customer ID, count order numbers as total orders from the orders table, where customer ID between 1015 and 1035, and group by customer ID and having total orders larger than 40. So in one query, we realize the functions defined for the problem defined above. We can actually applying having clause to more complicated queries such as involving joining multiple tables. The key concepts are the same. Having is needed when the filter requires results that are calculated from aggregating functions. Here's an example of finding customers that their total purchase is about $200,000. And here we're going to use the order table and order detail table. We're going to first join the order table and order detail table on the order numbers. And then we select the customer ID from orders table, and we then sum the product of the quoted price and quantity ordered from the order detail table, and we name that as the total spending. So here we're actually using a group by statement clause for the customer ID. So at the end of the day, there will be only one customer ID, and any of those quoted price, the product of quoted price and quoted orders for that customer ID will be all summed together, which is the total spending. And then because we're looking for the total spending is larger than $200,000, we're going to apply a having clause to make it happen. So we write, and then here's the result. So in this section, you learned how to use having clause to filter result after applying the aggregate function with the group by clause. So you also learned what's the difference between where and having. And this is the last piece of the grouping data section of the book. Hopefully you have already learned the fundamental ideas of group by and filtering and aggregating functions. Here's the homework assignment. Read through chapter 14 of the textbook. Do the following exercise for from the sales order database. First, use product vendors table. Find vendors whose average delivery days are less than 5 days. Second, use product vendors table. Find the products that their maximum wholesale price is higher than 1,000. 3. Use product vendors table. Only consider vendor ID between 5 and 10. Find the product's average price. Find the product's average price is less than 25. And that's all for today, and see you next time.